Hello, my dear students. My name is Dr. Rami Khan, and in today's video, I'm going to explain about hydrogen chapter from 11th standard. If you like this video, please share it to your friends, and I request you to watch this video up to the end. And if you are new to the channel, please subscribe to the channel. Okay, let me close this camera and then let's start the video. Hydrogen is the first element in the periodic table, and its atomic mass is atomic mass is 1, atomic number is also 1. So symbol of hydrogen is this one. Okay, so hydrogen position of, let us discuss about the position of hydrogen in the periodic table. Hydrogen is similar to both group 1, which are called alkali metals, and group 17, which are called halogens. So due to its similarities with both of these elements, group of elements, its position is not fixed in the modern periodic table till now. Okay, so so it is best to place separately hydrogen in some space in the periodic table. After its position, let us discuss about similarity of hydrogen with these alkali metals, which are group 1 elements, and halogens. Okay, alkali metals, let me take one example. Lithium has a tendency to lose one electron to form this lithium plus ion. So likewise, hydrogen also has a tendency to give out this only electron to form H plus ion. So in electropositivity, hydrogen is similar to group 1 elements. And with group 17 elements, let me take one example of group 17, that is chlorine. For example, chlorine has 17 electrons, 2, 8, 7, so its valence electrons is 7, so it can gain one electron to form chloride ion. Okay, so chloride ion completes its octet 2, 8, 8, so chloride ion is stable. So in the same way, hydrogen can also accept one electron to form hydride ion. So in electronegativity, tendency to gain electron, hydrogen is similar to group 17 elements, while in electropositivity, hydrogen is similar to group 1 elements, alkali metals. Okay, now after these similarities, let us discuss about dissimilarity with alkali metals and halogens. Okay, it is very easy to remove one electron from sodium or lithium, okay, in comparison to hydrogen. So the energy required to remove this electron from sodium is called ionization enthalpy, or ionization energy, or ionization potential. So ionization enthalpy of sodium is very, very low in comparison to ionization enthalpy of hydrogen. So in this regard, hydrogen is different from the tendency to give out electrons is same, but the amount of energy required to remove electron from hydrogen atom is comparatively higher than alkali metals. Okay, so in this respect, hydrogen is not similar to group 1 elements. Okay, while in case of this similarity with halogens, hydrogen is very not so reactive in comparison to chlorine, fluorine, bromine. These are all reactive elements. Okay, so in reactivity, hydrogen is not so similar to halogens, while we have other similarities, other dissimilarities other than this. For example, hydrogen is a non-metal, while group 1 elements are metals. This is also one of the similarities. hydrogen is S block element, while group 17 elements are P block elements. This is again one dissimilarity of hydrogen with halogens, one dissimilarity of hydrogen with group 1 elements. Okay, these are some similarities and dissimilarities of hydrogen with group 1 and group 17 elements. Okay, after this let us move to isotopes. So hydrogen has 3 types of isotopes, which are H11 and H21, H31. This is called protium, this is called deuterium, and this is tritium. Among these 3, tritium is a radioactive isotope of hydrogen, which means the nucleus of this tritium is not stable. This is the meaning of radioactivity. Okay, and this deuterium is a component of heavy water, and the topic of heavy water will be discussed later in this chapter. Okay, next topic is dihydrogen, means H2. So in the preparation of H2 in laboratory, hydrogen is prepared by reacting a reactive metal with an acid. H plus is acid to form this hydrogen gas. So let me write one full example. Zinc is a reactive element. We can take other reactive metal instead of zinc also. Zinc is reacted with, for example, HCl. HCl is an acid. So this zinc is more reactive than this hydrogen, so it can kick out this hydrogen, and so we will get zinc chloride along with hydrogen gas. This is the laboratory preparation of hydrogen. And in commercial preparation, which is the large scale preparation of hydrogen, that is called commercial preparation or industrial preparation of hydrogen. The first one is electrolysis of acidified water. This is our water, and in presence of an acid, if it is electrolyzed, the process is electrolysis. So we will get hydrogen gas in the cathode, while oxygen gas will be obtained at the anode. Okay, so this is also one of the preparations of oxygen gas. Along with hydrogen will be obtained at cathode, and oxygen will be obtained at anode. This is the first commercial preparation of hydrogen gas. Okay, second one is electrolysis of warm aqueous barium hydroxide between nickel electrodes. This preparation is used for the preparation of pure hydrogen. Approximately 99.955% pure hydrogen will be obtained in this preparation. Okay, the third one is byproduct in the manufacture of sodium hydroxide and chlorine by electrolysis of brine solution. Brine solution is nothing but an aqueous solution of what? NaCl के aqueous solution से सिगी brine solution को भी सिगी electrolysis तो हन्नु में तमदा we will get chlorine at anode and hydrogen gas at cathode, and sodium hydroxide, which is the alkali mentioned here, this sodium hydroxide, this will be obtained in the solution. Okay, so hydrogen is obtained as one of the products in the electrolysis of brine solution. Brine solution is saturated solution of NaCl. Okay, this is one of the industrial preparation of hydrogen gas, and this is also one of the industrial preparation of chlorine. Okay. Next preparation is by Bose process. This is also one of the commercial preparation of hydrogen. First, water gas is obtained. Water gas is a mixture of carbon monoxide and water, which is obtained by reacting carbon with water steam. Right, this is steam. This is not liquid water. This is gaseous water, and then the mixture is heated at 1270 Kelvin. Then water gas, which is mixture of carbon monoxide and water, will be obtained, and this this water gas mixture is further undergone this reaction. This is our this can be obtained by this reaction also, and or this is the example of this reaction. This is an alkane CnH2n plus 2, and it is reacted with steam and heated at 1270. We will obtain a mixture of carbon monoxide and water. In this case also, this is something an alternative source of carbon monoxide and hydrogen gas. Okay, here it is an example. Methane, this is propane. Propane is reacted with steam, and water gas is formed. In the second step, this hydrogen is separated from water gas. So this can be done by combining the water gas with again steam. This is steam, and the reaction mixture is mixed with Fe2O3. Fe2O3 is ferric oxide in presence of Cr2O3. So this carbon monoxide will be converted into carbon dioxide, and the hydrogen in larger amount, 2 mole of hydrogen is produced here. So we get a large amount of hydrogen here in this reaction. So this reaction is called water gas shift reaction. Okay, these are some industrial preparation of hydrogen. So let us move to the properties of hydrogen. Hydrogen, in the properties of hydrogen, first of all, hydrogen can react with halogens. These are halogens which can be fluorine, chlorine, bromine, or iodine. Hydrogen can be reacted with chlorine, for example, to form HCl. Okay, this is a very common example. H2 plus Cl2 gives HCl. Okay, in the second reaction, hydrogen can be reacted with oxygen to form water, and this reaction is exothermic in nature, and the energy released is 285.9 kilojoule per mole. Next one is reaction with nitrogen. This is also one of the famous reactions of chemistry, which is N2 plus H2 gives NH3, and this is Haber's process, industrial preparation of ammonia, and again the enthalpy change for this particular reaction is minus 92 kilojoule per mole. This is exothermic in nature. And next reaction is again with alkali metals. Hydrogen is reacted with M. This M can be our lithium, this can be sodium, this can be potassium. Okay, so hydrogen is reacted with alkali metals to form metal hydrides, MH can be, if M is sodium, then this will be our sodium hydride, like this, and this sodium will have a positive charge, hydrogen will be negative charge, and this is an ionic compound, and this compound is one of the examples of ionic hydrides. Okay, next reaction is reaction with metal oxide. This is not so important. Hydrogen is reacted with copper oxide. Since this hydrogen is more reactive than copper, it can kick out this copper to form water, and this is not sulfur, this is just copper. This is copper solid actually. This can be written like this, copper solid plus H2O liquid. And if it is reacted with Fe3O4, we will get iron and water. Next reaction is carbon monoxide. Carbon monoxide and hydrogen are reacted at 700 Kelvin, 200 atm pressure in presence of zinc and chromium oxide to form this methanol. So for this preparation, for this synthesis, this mixture is also called synthesis gas, syngas, water gas is also called syngas. So syngas is nothing but a mixture of carbon monoxide and hydrogen. Okay. Next property of hydrogen is very common reaction of organic chemistry. Hydrogen can be reacted with unsaturated hydrocarbon. Unsaturated hydrocarbon can be alkene or alkyne, and these hydrocarbons are reacted with hydrogen in presence of nickel or palladium or platinum catalyst, and if the reaction mixture is heated, then hydrogen will be added to this carbon atom to form saturated hydrocarbon, which is alkane. Ethane is formed by reacting ethane with hydrogen. Okay. Similarly, ethyne is reacted with hydrogen in presence of nickel or palladium or platinum catalyst to form ethane. These are some chemical properties of hydrogen. Okay. In the next part, I will discuss about hydrides, which are very common. These are some uses of hydrogen. Okay, hydride will be very important, so please watch the next video which will be uploaded. But for today, let me end this video here, because the video will be very long. If I complete this video in one lecture, then that will be very long. So for this video particularly, let me end here. So if you are new to the channel, please subscribe to the channel, and if you like this video, please share this video to your friends. Okay, thank you.